Hi everyone. I hope you guys had a great spring break. Enjoyed the week off. Enjoyed the week or the time with your families, and I hope everyone's staying healthy and safe. Um, so what I'm going to show you guys today, and what we're going to really focus on today, is evaluating non-special anglers, or non-special angles in that backward situation, like we've been doing before. So if you remember what we left off with last week is I showed you guys how to solve trig equations. And then at the very end of those trig equations, we had to go through and find the angle of those special angles and figure out what quadrants they're in and so on. So we're not going to do any trig equations today. Today's going to be kind of more of a review when we start to see non-special angles. So if you guys remember from class, anytime that we see non-special angles, we have to use our calculator. Now, if you guys have a graphing calculator at home and you remember how to do this, great. You might not even need this video to help you out. If you don't have your graphing calculator at home and maybe you left it in your locker, this video is really going to be helpful because what we're going to have to do is we're going to have to use what's called Desmos, which is a scientific calculator on your computer to help us out to be able to actually evaluate some of these non-special angles. All right, so if you guys look at the left of my screen right here, this left side, this is a document that actually Miss Kane created. That's great. It gives you guys like step-by-step walking through how to find everything when evaluating these non-specials. So the first thing, guys, is here's a calculator off to my right. Here's what it's going to look like when you guys bring it up. And if you go, and I'm going to put this attachment on Google Classroom too, but if you go to this first link right here, this is going to bring up the calculator that you're going to need to evaluate these non-specials, which looks like this. I just wanted to split my screen so that you guys can see both. So we go through, here's some important kind of things to know and buttons to use when actually trying to evaluate these non-special angles. So first thing is, if you look here, making sure that you're in radian mode, right? So we want to switch this over to radians. Anytime that you have numbers and operations, which is like your main function, that's when you're going to see your numbers here, your operations. But in order to get to inverse trig, which we're going to need because that's how we find all of our angles, up here, if you look at this tab in this calculator, you're just going to go to functions. And once you click functions, then you're going to see your inverses right here, sine, cosine, and tangent. All right. The enter button is just going to be that blue button. And then if you guys need to find the pi symbol, because remember, anytime that we find that reference angle, we need to think about the closest x-axis and either go subtract it from the closest x-axis or add it to or subtract. So we need that pi symbol in there. And as long as you're on that function tab, that pi symbol is going to be right next to that enter button all the way down here. All right. So I'm going to go through and do two of these with you, one based off of this document example to the left, and then one I'll actually do with you guys from the assignment that I'm giving you today. All right, so if we look at our first example here, and I know it's all laid out and all the steps here, and your answers are even down there too, but I just want to do this kind of in real time so that you guys can definitely see this. All right, so for our first example here, we have sine of x is equal to 4/5. And we know 4/5 obviously isn't corresponding to a special angle at all. So the first thing that we have to do when we want to try to find this is we want to use our inverse trig to find our reference angle. So if I go over to my calculator on this right side, the first thing I want to do is making sure I'm in radians, which I am. I want to do the inverse of sine, and then I'm going to type in after that 4/5. So 4 divided by 5. All right. All right. So once you have that, and it actually shows you right here, but you can hit enter, and that's going to give you your reference angle. So in this case, our reference angle ends up being 0.927. Okay. So once we have our reference angle using our calculator, now in this case, since we know that we're working with sine and we have a positive 4/5, we want to think about the quadrants in which y is positive. Because remember, we always end up having two of these angles. So if we go back and think about our reference or think about your quadrants right here, we know y is positive in quadrant 1 and in quadrant number 2, right? So anytime that we're in quadrant 1, we know one of our answers is just going to be that reference angle. So one of my answers is 0.927, and that's how we get that, right? But the other thing we need to do is find that angle measure in quadrant 2. So anytime that we're in quadrant 2, we know our closest x-axis is pi. So I have to subtract pi from my reference angle. All right. So since we know our reference angle is 0.927, which we just found, all we want to do is take our closest x-axis of pi, go back to our main tab so we can hit the subtraction sign, and then we're going to subtract from that our reference angle that we found before. And once we do that, that's going to give us our second angle in radians that lies in quadrant 2, which is 2.215. And those would be your guys' two answers for this. All right. So again, I just want to show you guys and walk through how to use this Desmo calculator, because I know it can be maybe a little bit weird. Maybe you haven't seen it before, but this is a really, really good document to kind of go back and refresh, or maybe not even refresh, maybe learn how to use Desmos as a calculator for this inverse trig stuff. All right. So let me see if I can do this correctly. So let me try to bring up and slide over. Okay. All right, so what I'm going to do now is, here's your guys on the left. This is the assignment that I actually want you completing for today, but I'm going to pick out one of these problems to do just to show you guys another example of how to do this using this Desmos calculator over here. So let's look at, let's look at a negative. So that means we're not going to be in quadrant 1. So you know what? Let's look at problem, and can I draw on this? I can't draw on that side. All right, but let's look at problem number 4. So on problem 4, we have cosine theta of a negative 4/5. Okay, so let me go back to that. Okay, all right, so when you guys are doing problem number 4, if you remember with non-special angles, I know the first thing we have to find that reference angle, but we never want that reference angle when we're typing this in to be negative. All right. So when we go through and do this, our first step is finding that reference angle. So since I'm working with cosine, I have the inverse of cosine. Now I don't want to type in a negative 4/5. I actually just want to type in 4/5. All right. Leave that positive, because leaving that positive gives you your correct reference angle. And again, just make sure you're in radians. But once you do the inverse of cosine of 4/5 and hit enter, that's going to give you your reference angle. So in this case, let me draw this up top, baby. Our reference angle ends up being 0.644, right? Okay, now if we look back at number 4, the next thing we got to do is figure out what quadrants we're in. Since cosine in this case is equaling a negative 4/5, and this is a negative value, what we're really saying is that x is now negative. So the two quadrants that x is negative is quadrant number 2 and then quadrant number 3. So when we're looking at quadrant 2 and quadrant 3 to find our special angles, we know our closest x-axis is pi. So to get to quadrant 2, like we talked about before, quadrant 2, you're always going to subtract from pi, that reference angle from pi. So I'm going to subtract. I'm going to go and, let me make sure I change this. So I'm going to go down here and have pi and subtract from pi my reference angle of 0.644. All right. So that would give me that 2.497. That's one of my angles lying in quadrant 4. So I know that just kind of wiped away some of it. But one of my angles, one of my answers here is going to be 2.497. All right, that's going to be in quadrant 2. Now, when we go through and we find that angle measure in quadrant 3, we have to do the same thing. We just have to add our reference angle onto pi. All right, so if we go back to pi in our functions tab, go back to main, and we add our reference angle of 0.644. All right, that gives us, oh, I'm sorry, I hit multiplication. Let me go back and do that again. I'm sorry, I hit the multiplication side. So that answer didn't make much sense. All right, that answer makes a lot more sense. So your second answer would then be 3.75. I'm sorry, 786. All right, so our two answers would then be 2.497 or 498, I guess, and 3.786. All right, those would be your guys' two answers. So I hope this helps you use that Desmos calculator. If you guys have any questions at all, just write me a comment through Google Classroom, email me, or you can hop on that Google Meet session that we're going to have later today. All right, have a good day, guys. I'll see you later.